Hey guys, welcome back to our YouTube channel Tech Begin. Yesterday we started data structures. Previously we all learned about the C and all, and yesterday we started a new subject named data structures, and also we learned about the introduction part and all, and now it is day 2 to learn about the data structures. And today our topic is about linked list. Understanding and implementing linked list. First slide is introduction to linked list. First of all, the definition. A linked list is a linear data structure where elements are stored in nodes and each node points to the next node in the sequence. Comparison with arrays. Unlike arrays, linked lists do not require contiguous memory. They are ideal for scenarios where frequent insertion and deletion operations are required. And types of linked lists. Before going to the types of linked list, we should know about the nodes and what is the node and what is the purpose of nodes in linked list. Actually, the node consists of two parts, that is the data part and another one is the pointer part. The data part is used to store the value and the pointer part is used as a reference to the next node. And then the types of linked lists. First one is singly linked list, second one is doubly linked list, and the third one is circular linked list. Here single linked list structure should be given. In singly linked list, the node is equals to the data and next pointer. The single linked list is a simple linear structure. The nodes point in one direction. It only points in the single direction, either the left side or the right side. And this is the structure of singly linked list. Here A, B, C, D are four different types of nodes, and A is tends to the head where the A is data part and the right side the remaining half will be the pointer part, that is nothing but the next part, and the next points to the next node, that is the second node, that is B, and the second node next part points to the third node C, and the third node next part will as usually follow towards the fourth node, that is D, and finally when we reach the last node it points towards the null point. Here this is the structure of a node. The node consists of two parts, as I already said. The first one is the data and the second one is the next. And similarly, there will be some few more nodes to follow. The second node and the third node also consist of the same two parts, that is data and the next. Here the node 1 next part points towards the node 2 data part, and similarly node 2 next part follows the node 3 data part, and finally when the list is completed it points towards the null. As always you should remember that the node 1 must and should will follow the head part only. And the next list is and the next linked list is doubly linked list. Doubly linked list is a linked list where each node has two pointers. Beforely we already discussed that singly linked list consists of only one node, points towards the one direction, but here each node has two pointers. Single linked list has only one pointer and doubly linked list has two pointers. That means one to the each node and one to the previous node. In the doubly linked list, one points towards the right side, that is the next node, and another one points to the left side, that is the previous node. Let us see the structure. This is the structure of doubly linked list. Here A, B, C, D are 4 nodes, and A consists of data part and next part, whereas B also consists of data part and next part, and C, D also consists of the same 2 parts. But here A consists of 2 half parts, one data part and 2 next parts. That means one to the B and one to the head part. That is the next one and the previous one. And similarly, B contains of one data part and 2 next parts. And here we call 2 next parts as one is the next and another one is the previous, as it points one to the right side node and another one points to the left side node. So here it is called as next and previous, and in singly linked list it is only next, and here it should be divided into 2 parts since it is pointing to 2 different nodes. Then the third type is circular linked list. Here last node points back to the head, that is it should form as a circular motion, it should form a circular structure, and that type of linked list is called as circular linked list. Let us see the structure of circular linked list. This is the structure of circular linked list. Here A, B, C, D are 4 different types of nodes, and A next part is pointing towards the B data part. Similarly, it looks like the singly linked list, as it contains only one pointer. It is similar to that of singly linked list, but whereas D points towards the null in singly linked list, but in circular linked list it should point again towards the node 1, that is node A. It should form a complete circular shape, so that it is called as circular linked list in data structures. Here singly linked list operations overview is the next slide. Not only for singly linked list, but it also applicable for the doubly linked list too. And the operations here used are creation, insertion, deletion, traversing and searching. Then operations. Here insertion and deletion are done in 3 types, that is insertion at beginning, insertion at end and insertion at specific position in the case of insertion. While coming to the deletion part, deletion from beginning, deletion from end and deletion from specific position. These are the 6 types. Separately we can tell it as insertion part and deletion part. Insertion part consists of 3 types and deletion part consists of 3 types. Whereas traversal, it starts from the head and visit each node by following the next pointers until null is reached, and it is called as traversing. While coming towards the searching part, compare the target value with the data of each node during the traversal is called as searching. Then creating a linked list is the next slide. Here we should follow 3 steps. The first step is create linked list object, And the second step is create first node, and the third step is link it to the list. And if we follow the three steps perfectly, then we can create a single linked list easily. The next slide is insertion in singly linked list. We already discussed that insertion is taken place in three parts, that is insertion at beginning, insertion at end, and insertion at specific position. First, insertion at beginning. We should follow the following steps to insert at beginning. Create a new node, then point it to the current head, then update head to new node. And these are the three steps that should be followed for insertion at beginning. Then insertion at end. Traverse to the last node and set its pointer to the new node. These are the two steps that should be followed for insertion at end. While coming to the insertion at specific position, the following steps should be taken. Traverse to the node before the desired position and update pointers accordingly. These are the two steps that we should take to insert a node at a specific position perfectly. This is the structure of insertion at beginning in a singly linked list. Here, as we already talked about the steps, the first one is create a new node. That means we created a new node here which points to the current head, and then we should update the head to the new node. And then this is insertion at end of a singly linked list. We also discussed this insertion part at the end. First, we should traverse at the last node and set its next pointer to the new node, so that we can again set its point towards the null pointer. That means here the D points to the null, but we removed that null, and in the place of null we inserted another node E which points towards the D. So D points towards E and then E points towards the null, and this is insertion at the end in singly linked list. This is the structure of insertion at a specific position in singly linked list. Here D points towards the C, but we removed that point, and the B node which contains the next part is pointing towards the E part with data, and the E's next part is pointing towards the C data part, so that another node, that means the new node E, is inserted between a certain position, that is between C and D. Then the next slide is about deletion in singly linked list. Here also we contain three parts, that is deletion from beginning, deletion from end, and deletion at a specific node by value or position. Here deletion from beginning consists of the following steps to done perfectly. Update head to point to the next node and delete the first node. While coming towards deletion from end, the following steps must be necessary. Traverse to the second last node and set its next to null. And then the last one is deletion from a specific position. Adjust the pointers to skip the node to be deleted. And by following the following steps, we can easily do the deletion either from beginning or end or a specific node. Now let us see the structure of deletion from beginning and from end and from a specific node. Here, this is deletion at beginning structure in singly linked list. As we already discussed, the steps that should be followed is traverse updating. Here, head is pointing towards the node A, but we want to delete that node A so that we points the head towards B, so the node A is removed easily from the linked list. This is the structure of deletion at end in a singly linked list. Here it is also updating just so that the last node is removed easily. Here the last node D is pointing towards the null, but we want to remove that node D. So the C node is pointing directly to null, and so the D is removed successfully. This is deletion at specific position in a singly linked list. In singly linked list, at this particular deletion part, we use the method called as ignoring. Here simply we ignore the node C for deletion. B points towards D and C points towards D. So here we want to remove that node C, and that's the reason why we ignored the C and we directly pointed B towards D successfully. And if we pointing that D from B, then obviously C is removed and it is also ignored. And the next one is traversing singly linked list. Here loop through using next pointer will be used and print each node's data. Then the last operation in singly linked list is searching. Here we used the linear search logic. It returns the index or the pointer. While coming to the doubly linked list structure, the node consists of the data and also the next and the previous part. It supports backward traversal, while the singly linked list support only one-way traversal. Here also the operations used in doubly linked lists are insertion, deletion, creation, traversing and searching. And all the creation, insertion, deletion, traversing and searching is similar to that of singly linked list. Here also the insertion consists of three parts, that is insertion at beginning, insertion at end and insertion at a specific position. And also the deletion operation also consists of three parts, that is deletion from beginning, deletion from end and deletion from a specific position. It is more flexible than the singly linked list operations. Here the operation is also done with the another pointer, that is from the other way. This is the structure of insertion at last in doubly linked list. It is also similar to that of singly linked list, which is already discussed. Go through the structure once. This is the insertion at beginning in doubly linked list. It is also similar to that of the singly linked list. The only difference we can see here is in singly linked list it points only one node, while in doubly linked list it points two nodes, that is in both the directions from a single node. And this is the insertion in middle in doubly linked list. In doubly linked list, traversal means start from the head and visit each node by following the next pointers until null is reached from the either sides. And searching means Compare the target value with the data of each node during the traversal from either sides. Then the last type of linked list is circular linked list. Here the last node points towards the head again. Here this is the structural diagram of circular linked list. Here D is the last node and the D points again towards the head point of A node. And though it forms a circular path and so it is called as circular linked list. The next slide is about advantages of linked list. The first one is dynamic size. Linked list can grow or shrink in size during runtime. There is no need to specify initial size like we do in arrays. And the second one is efficient insertions or deletions. Inserting or deleting elements, especially at the beginning or middle, is efficient. No need to shift elements like arrays. And the third one is memory utilization. It allocates memory as needed. It is useful for applications where the number of elements is unknown or changes frequently. No wasted memory. Since there is no pre-allocation, memory isn't wasted. But in case of arrays, there is a wasting of memory. The next one is implementation of abstract data types. Linked lists are foundation for advanced structures like stacks, queues, graphs, hash tables, and space matrix. And the last one is flexibility. Nodes can be easily rearranged, useful for real-time systems that need dynamic memory management. Then the next slide is about disadvantages of linked list. The first one is no random access. We cannot directly access an element by index like we do in arrays. Must traverse the list from the head to reach a specific node. And the second one is extra memory for pointers. Each node stores a pointer that is next in addition to the data. This overhead can be significant in large lists. The third one is slower access time. Searching for an element takes big O of n time. Arrays also faster access with big O of 1 indexing. And the fourth one disadvantage is more complex implementation. Linked lists are more complex to implement and manage than arrays. It involves careful pointer or reference handling. And the fifth one is poor cache locality. Nodes are stored in non-contiguous memory, as we already know. Leads to poor performance in terms of CPU caching compared to arrays. And the last disadvantage is risk of memory leaks. Improper memory management, especially in languages like C or C++, that can cause memory leaks if nodes aren't properly deallocated. These are the advantages and disadvantages of linked list we discussed. And the next slide is linked list use cases. Linked lists are the foundation for advanced structures like stacks, queues, graphs, hash tables, and space matrices. There are some differences between arrays and linked lists, which is most frequently asked questions. And the first one is fixed size. In arrays, the size is fixed because resizing is expensive, whereas in linked lists, the dynamic size will be presented. In arrays, insertion and deletions are inefficient because elements are usually shifted. In linked list, insertions or deletions are efficient. That means no shifting. In arrays, random access, that is efficient indexing, will be there. And in linked list, no random access will be presented because it is not suitable for operations requiring accessing elements by index such as sorting. In arrays, no memory waste if the array is full or almost full, otherwise may result in much memory waste. In linked list, since memory is allocated dynamically, that is according to our need, there is no waste of memory. In arrays, sequential access is faster, and the reason behind this is elements in contiguous memory allocations will be presented. In linked list, sequential access is slow, and the reason behind this is elements are not in contiguous memory allocations. And then the next slide is practice problems. The first one is reverse in linked list, and the second one is detecting the loop, and the third one is singly linked list insertion and deletion. And the last slide is about summary and what's next. We should recall the singly linked list, doubly linked list, and the circular linked list, that is the types of linked list, and also the operations we discussed that are done in linked list, mainly the insertion and deletion parts. And also you should learn more about the insertion and deletion types too. That means the three types, that is insertion at the beginning, insertion at the end, and insertion at a specific position, and also deletion at the beginning, deletion at the end, and a deletion at a specific position. And we should also learn about circular linked list with their structures too. And stay tuned for our next class. Thank you.